Hello everyone, in this video I will be talking about basic exploratory data analysis. So when I say exploratory data analysis, I am talking about analyzing the data. So whenever we deal with any machine learning problem, so we cannot directly work on the data. Before that, we have to clean the data. We have to check if our data is in proper format or not. So for that, we perform EDA on the data set which we have. So also it helps in manipulating data by discovering the patterns, by finding the anomalies, and we make certain assumptions about the data after analyzing it properly. So one should have a proper understanding of the data before working on it and passing it to a machine learning model. So this is the basic introduction. Now I'll move to the practical implementation, like what all things we can do in data analysis. So here you can see whenever we talk about any data science problem statement, first we have to understand the problem description, then we do data mining, then we do data preparation, and here comes the exploratory data analysis. After doing this analysis and getting the insights about data, we move to the feature engineering and then model building and finally the model evaluation. So there are basically libraries which we use for data analysis. These are NumPy, Pandas, and for visualization purpose, I'm using Matplotlib and Seaborn. For plotting any graphical charts and all, everything, we can do it using the Matplotlib and Seaborn. So first I'm loading the data set. So I have a data set in the CSV format and its name is animation underscore predict. So here I am reading the CSV file. Now I want to eyeball the data, like what all columns and rows we have in a data set. So I am using df.head. So df is basically the data frame I have created, and inside that I am loading my file. Head basically shows the first 5 records of the data set you have. So here you can see I have columns like serial number, GRE score, TOEFL score, university rating, and so on. And now I'm checking the data types for each and every column. So here you can see like I have data types of integer, float type. So like this, using the dtypes function, you can check the data types. Then you can check the shape of the data. So it is basically checking the dimensions, like how many rows and columns I have in a data set. So currently I have 400 rows and 9 columns. Then I'm checking what all columns we have using df.columns. So here you can see like I have columns called serial number, GRE, TOEFL score, and so on. Then counting the data types, like you can use value counts for like the number of data types you have. Like you have 5 columns which are of integer type. You have 4 columns which are float type. And then you can check additional information using the info function. So here you can see you will get complete information about the column name and if there are any null values present in a particular column and what all data types they belong to. Then I'm doing some descriptive data analysis over here. So when I talk about the descriptive data analysis, like it's basically how it describes about the central tendency, like mean, median, and mode. So mean is basically for calculating the average. So here I'm calculating the mean for each and every column over here. Then using df.median, I'm checking the median for each and every column. And mode is basically like which is the most frequent uh, element occurring in a particular column. So like this, you can check the central tendency measures using these functions. Then I'll be talking about measure of dispersion. So measure of dispersion basically deals with how dispersed our data set is on our feature space. So here you can see like how basically our data is spread over particular regions. So those things you can check it using the measures of dispersions we have. So for calculating that, we have a variance, range, standard deviation, and coefficient of variance. So basically, I'm here checking the also, you can check the quantiles like 25% quantile, 50% quantile using the function called quantile, and I'm passing the parameter over here. Like if I want to check what is the quantile at 0.50%, then I can check it, and 75% quantile. And then I'm checking the interquartile range over here. Like I'm just subtracting the highest with the lowest range I have right now, that is the 75% quantile and the 25% quantile. So such kind of analysis you can do. And then I'm checking the range. So range is basically the difference between the minimum and maximum of a particular column. So using range function, you can check the range of the column of data set. And then here I'm checking the variance using the var function. You can check the variance of the data set for each and every column. Then I'm checking the standard deviation. So you can use the std function to calculate the standard deviation for all the columns. Also, you can check the five number summary. So five number summary is basically includes the minimum, maximum, quartile 1, quartile 3, and the median. So these are basically the five number summary states. So you can check the five number summary using the describe function over here. Also, I'm doing a transpose so that it is more readable. So here you can see for serial number column, I have a mean this, then I have the minimum value this, maximum is 400, and also it gives the standard deviation, some extra information, and the 25%, 50%, and 75%. So if you want to check some 99%, like in some cases, so what you can do, you can just write 99 over here. So it will display the 99% of the data. So you can just check for the different, for example, if I want to check 78, what should be the 78%, then you can do it like this. You can check what is the data you're getting at the 78%. Then I'm checking the, uh, I'm plotting the box plot. So box plot also helps you in getting the five number summary. So here you can see in a box plot there are some whiskers. So these lines kind of thing is called whisker. This is the minimum whisker and this is the maximum. So you will find two whiskers in a box plot, and the range from Q1 to Q3 is called the interquartile range, that is called IQR, and the middle part is the median. So using box plot, you can get a complete picture of the how properly your data is distributed, and also you can check the outliers. So if you find any data points which are below the minimum value or which are above the maximum value over here, then you can check it using the box plot. So this is widely used for detecting outliers in a data set. So here, if you see, I'm plotting a box plot over here. And here you can see for column LOR, I can see some small circle over here. So this is basically saying like there's some outlier over here for this column. Also for the chance of admit, there's some outlier. So you can either delete it or you can cap the outliers. So here I'm capping the outlier if it is greater than 3. So here I'm just capping it so you can see the number of outliers we have. Here I'm counting the number of outliers, and yeah, so now the next thing what I'm doing is talking about the covariance and coefficient of correlation. So this is another measure for the measure of dispersion. So covariance is like basically how linear relationship exists between the variables and the value lies between minus infinity to plus infinity, and negative relationship indicates like there's a uh, covariance is very weak, and positive relationship indicates it is strong. And if the covariance value is zero, it means like there's no relationship between the variables. And then we have another measure, correlation. So it basically talk about the strength of a relationship, how strongly two variables are connected with each other, and its value lies between -1 to +1. And it shows like if we have value close to 1, it means that they are strongly associated with each other. -1 indicates like they are weakly associated with each other. So you can check covariance with a COV function and correlation with call. Also, you can plot a pair plot. Here also you can visualize like if there's a positive correlation or there's no clear correlation at all. So you can visualize it using pair plot as well. Also, you can visualize data using the heat map. So in heat map also you can see like if the shades are lighter, it means there's a weak correlation, and if it is more darker, it means like there's a strong correlation between the two variables. And then we can also check the skewness and kurtosis of the data set. So skewness means how your data is distributed over a feature space. So if I'm talking about the positive skew, so it means it is pointing towards the right tail. And when I'm talking about negative skew, it means like it points towards the left tail. And the data is called normally distributed if it is in the bell curve. So here you can see at this point the value how the mean median mode differs. So this is how you can check the skewness. And yeah, that's all. So here I have just talked about the basic EDA you can perform in any data set to get some insights. So if you really like the video and if you really like the way of my explanation, please share, subscribe, and hit the like button. Thank you. Bye bye.